Hello everyone, welcome to Cambridge Guru once again, and we are doing further integration, and in that we have already done integration by substitution and then integration which involves some trigonometric functions, and last video was about integration which involves partial fractions, right? Last topic in this unit is integration by parts. Okay, so let us start. Integration by parts, this is you can say a counterpart of the product rule in differentiation. For example, if you have any two functions which are in multiplication, and two functions, I mean to say that they are of different kinds, right? For example, as you can see on the screen that if we have to integrate x into cos x, so one function is your algebraic function and second function is trigonometric function, and these two functions are in product. So just like we have a product rule in differentiation, so is there any counterpart for that in integration? So answer is yes, and that is your integration by parts, right? But somehow it is not like that we integrate first x and then we integrate cos x, right? So integration of any two functions which are in multiplication, basically we cannot apply the product rule as we apply in differentiation. Okay, it's you can say the integration of two functions or integration by parts. It is, you can say, a more derived form of integration by using product rule. Okay, so exactly we cannot say that this is a product rule, but it is a byproduct. Okay, all right. So as I was saying that if you have any two different types of functions, one is, let us say, algebraic and second is trigonometric. So how to integrate these two functions, right? The method that we are going to introduce is not the method, but you have a series of functions that you need to follow in order. In order mean to say that you will call, out of these two functions, you will call one function as first function and second function you will call as the second function, right? And which function I will call as the first function and which function I will call as a second function, that will be decided by following a series of function, and in short it is called ILATE, right? So integration by parts is basically introduction of this rule, which is ILATE. I stands for all the functions which are inverse function. Okay, and basically inverse trigonometric functions. So I will write here as inverse, right? For example, sine inverse x, cos inverse x, tan inverse x, and so on. Okay, L stands for logarithmic function, log function, simple ln x, and so on. And A stands for algebraic, T stands for trigonometric, and E stands for exponential function like e raised to power x, e raised to power 2x, and so on. Okay, this is your exponential function, right? So I stands for inverse. So you will, if you have any function, let us say if you have to integrate integral of x tan inverse x. Okay, so here if you have to integrate x tan inverse x, so in this you will say that tan inverse x is my first function and x I will call as the second function, because in that order I comes earlier compared to this algebraic A. Okay, so now why we are saying this is first function and second function, because now we have to use one formula for integrating by parts, and that formula you will call this as that if you have to integrate any two functions, I'm calling one function as u, second function as v. So if you are integrating uv dx, so formula for this is that you will write this, let us say you are denoting u as my first function, right, and v as second function. Okay, let us write this as just first into second function. Okay, just remove these, and now you have to integrate first function into second function, and this function first and second, they are decided by the ILATE rule. Okay, so this is equal to that you will write first function as it is. You will multiply this by integral of second function. Okay, then with a minus sign. Now here is a trick, not a trick, but a more, you can say, different part as compared to product rule in differentiation, is that here you will differentiate the first function. Okay, you will differentiate the first function and then multiply this derivative with the integral of, again, second function. Okay, now once you have got this differentiation multiplied by integral of second function, again you will get one function, because integral of any function you will get one function, whether that function is constant or anything. Okay, so integral of second function is again a function, and derivative of this first function you will get another function, right? And then you will integrate this whole with respect to dx. Okay, so the formula is that you will write first function as it is, integrate the second function, minus, you have to first find out the derivative of first function, then integral of second function again, and then again integrate the product of these two, right? So now we have integral of, for example, as the question was saying, that you have to integrate x cos x dx. Okay, so I am calling x as my first function because according to Eilert, A comes first compared to t, which is trigonometric, right? So x will be first function and cos x will be my second function. Okay, so I'm calling this as first and this is second. So now the solution is that you will write first function as it is according to this formula. So my first function is x, so I'm writing this x as it is, and then multiplying this by integral of second function. So I have to multiply this by integral of cos x dx, then apply a minus sign, apply this big integral sign. Now you have to differentiate my first function, which is dy dx of x. Okay, and then you have to multiply this with integral of, again, cos x dx, right? And then integrate this whole product with respect to dx. Now let us evaluate these quickly. So integral of cos x is sin x. So this is my x into sin x, right? Minus this integral sign, bigger one. D by dx of x is 1, and 1 multiplied by the integral of cos x, which is sin x, right? So 1 multiplied by sin x and then dx, and lastly integral of sin x is minus cos x. Okay, this minus and that minus will become plus, so x sin x, right, minus, and this integral of sin x is minus cos x, right? So it will become plus cos x, and plus c, of course, the constant of integration. Okay, so if you remember this Eilert, of course you will remember because it is a plain English, and you can also make the full form of these letters I, L, A, T and E, right? And then decide which function you will call as the first and second function, and then you have to remember this formula, that first function you have to write as it is, integrate the second function, and then minus sign, differentiate the first function, multiply that with integral of second function, and again finally integrate that product. Okay, so let us take another example. Let us say this, that we have to find integral of 2x e raised to power x, right? So according to Eilert, a comes first or earlier compared to exponential function. So again, this x, I'm calling this as the first function and this is the second function. So I'm writing this as 2 I can take outside, okay, no harm in this, and integral of x e raised to power x dx, right? So this is equal to 2 outside. What I will do is first function as it is, and integral of e raised to power x is simple e raised to power x. So x into e raised to power x, I'm writing this directly, that integral of second function is e raised to power x. So after integrating, I'm writing this, right? Apply the minus sign. Now integral of derivative of x is 1, and 1 will be multiplied by integral of e raised to power x, which is again e raised to power x dx. Okay, so this is 2x e raised to power x minus e raised to power x integral is again e raised to power x. So minus, you can multiply this 2 inside. So minus 2 e raised to power x. Okay, you can take 2 e raised to power x outside. So it is x minus 1 plus c. Okay, this is your final answer. Okay, it is very simple if you remember the formula and the rule ILATE, right? Let us do a couple of more questions. Right. Next is that if you have to integrate by parts twice, so you will get some question in which within the integral you have to again apply the integration by parts. Right. What I mean by this is that if let us take one example that you have to integrate x square sine x this time. Okay. Now according to ILATE, a comes earlier than t, so x square in this case is your first function and sine x is your second function. Okay, so this integral will be equal to, now think in your mind that first function you will write as it is, which is x square, and integral of second function, which is sine x, which is minus cos x. Okay, so I'm writing directly this as minus x square cos x. Again, I am repeating that this x square will remain as it is, first function, and integral of sine x will be minus cos x. Okay, now with the minus sign, you will apply integral, that bigger one, and derivative of x square will be 2x. You will multiply this 2x with integral of sine x, right? Integral of second function, which is minus cos x. So what I'm doing is, okay, let me write this integral of, let us say, sine x. Okay, if you are getting confused with this and this, you will integrate with respect to dx. Okay, make this habit to do these integral in mind. Okay, but yes, you have to be very careful that calculation should not be wrong. Okay, so minus integral this sine 2x, so integral of sine x will be minus cos x. That is what I was saying earlier. So that minus and minus will become plus. Okay, I can take this 2 outside. So now you have this inside the integral sign is x of x cos x dx. Okay, because integral of sine x is minus cos x, minus minus is plus, so it is integral of x cos x dx. Now here, as you can see, that this again is an integral which involves x cos x. So x is an algebraic function and cos x is a trigonometric function. So again, you have to apply by parts within the question. Okay, so that's why the heading is that using integration by parts twice. Right, you may get some question where you have to integrate by parts thrice had it been x cube, right? So you have to apply again integration by parts, right? So it depends on the what kind of function you are getting. Okay, so now it is minus x square cos x plus 2 I can take outside. Again, I am applying integration by parts. So first function is x, it will remain as it is. Integral of cos x is sin x. So it is x sin x minus sine. Derivative of x is 1, right? So integral of 1 into integral of cos x is sin x dx. Okay. Now last step is minus x square cos x plus 2x sin x and minus integral of, again, sin x is minus cos x, that minus and minus will become plus, and multiplying this 2 inside, it will give you 2 cos x dx. Sorry, not dx, plus c. Okay, this is using integration by parts twice. Now last topic in this is that suppose you have been given any function of the type, let us say you have to integrate, I'm calling this as integral I as integral of let us say e raised to power x cos x dx. Okay, So e raised to power x cos x, this is your function, right? So here you will write this cos x as your first function and e as second function, because according to Eilert, t comes first, then e. Okay, so now e raised to power x is my second function. Now solution for this is first function as it is, which is cos x, multiplied by integral of second function, which is e raised to power x. So it will be e raised to power x minus sine integral of derivative of first function. So derivative of cos x is minus sine x. So this minus and minus will become plus. So it is plus sine x, and again integral of e raised to power x will be e raised to power x, and this is dx. Okay, now as you can see here, I am just simplifying this e raised to power x cos x plus integral of e raised to power x into sine x. Now as you can see here, it is just an extension of the previous topic, which was using integration by parts twice. So here again you are seeing that there are two functions in multiplication. Excuse me. One is exponential and second is trigonometric. So you will apply integration by parts again. So let us see what we will get after applying this again. So again the first function is sine x and second function is exponential. So let us apply a bracket here. First function will remain as it is. So it is e raised to power x, integral of e raised to power x, e raised to power x, and sine x will remain as it is. Okay, apply a minus sign, then integral of into derivative of first function. So derivative of sine x is cos x, right? And again integral of e raised to power x is e raised to power x dx. Okay, so now it is e raised to power x cos x plus e raised to power x sin x, and this is minus of integral of e raised to power x cos x. Now you will see a very interesting phenomena here, that this is again e raised to power x cos x. Again you will get a product of two functions in multiplication. So you will apply again integration by parts. The moment you apply integration by parts, again you will get in place of cos x as sin x. So what you are noticing here, that initially I have the function e raised to power x cos x. You apply integration by parts, right? You get e raised to power x sin x. Again you apply integration by parts, this sin x is becoming cos x with an alternate plus and minus sign. You will apply again integration by parts, you will get sin x. So this sine will be converted to cos, cos will be converted to sine. You won't be relieved by this integral sign. Okay, this integral of e raised to power x, either cos x or sin x, will get repeated. So now what we have to do, right? So there is a trick here, that as you can see that at the start I have written this, my original function, original integral is denoted by I, capital I. So what you are seeing here, that in the third step, means when you have applied the integral by parts again, so you arrive with this again e raised to power x cos x, which is your initial integral. Okay, so you will denote this by I. Okay, that means in the LHS you have I, in the RHS you have e raised to power x cos x, right, plus e raised to power x sin x, and what this is, it is actually minus sign for this, it is I, right? So here it is plus I, here it is minus I. You can transfer this I to left hand side. That means twice of I is e raised to power x sin x plus cos x. Okay, inside the bracket. So value of I is, you can transfer this to RHS, it is e raised to power x over 2 sin x plus cos x. Okay, this is your final answer, right? So this is third variety of question that you will encounter, that sometimes you are applying integration by parts again and again, and you you will see that there is some pattern involved in the question, right? So look for that if I call the initial integral as I, is there any integral which is of the same type as in the original question, and consider that integral as just I. Okay, so that's all in integration by parts, and you will get different question which involves substitution also, right, and which will involve some definite integral that hardly matters. I just have to introduce that how to apply integration by parts, what do you mean by isolate, what is the formula for integration by parts, and the three types of questions that you will encounter. Okay, so from my side, further integration is also over, right? And I think we have only 2 topics left as far as pure mathematics A level, paper number 32 is concerned. Okay, see you soon in the next video. I will come up with the next topic, which is, I think, vector. Okay, till then, take care, bye bye, and please like, share, and subscribe my channel. And if you have any doubt, please mention in the comment section. Any video, particular topic you want to discuss, if you have any facing problem in any particular question of any topic as far as 9709 whole syllabus is concerned, whether it is related to statistics, paper number 62, or pure maths, please mention that in the comment, right? So thank you very much for listening this patiently. See you very soon. Bye.